Howdy, greetings and salutations. What I've got for you today, AP Chemistry fans, is another way to find out the delta H of a chemical reaction. And we use an equation which is the products minus the reactants. This requires that we look up some values and requires, I guess, we have a balanced equation to work from. So I'm going to choose a combustion reaction because I enjoy those. And we're going to use methanol. So I have CH3OH plus O2, and this gets me CO2 plus H2O. And with all chemical reactions, we have to balance this thing. So I put a 2 here, a 3, a 2, and a 4. And this balances everything involved. And what we eventually want to find out is what is the delta H for this? Now, there's a bunch of ways that we could find a delta H. In this case, we're going to look up some values. We're going to look up the heats of formation for all of the concerned products and reactants. So let's look up that for each of these things. Perhaps I will change colors and say the heat of formation, delta H, with an F and a little degree sign, equals. Now for the CH3OH, it happens to be a negative 201.2. Oxygen is in its standard state, so it's 0. CO2 is negative 393.5 kilojoules. And water, we would assume leaves in the gas phase, which makes a difference. You do have to look it up in the gas phase, and it's negative 241.82 kilojoules. Now we have this equation that will say our delta H equals the sum of our products minus the sum of our reactants. And we have some reactants, we have some products. We do have to be careful to honor the coefficients that are in front of everything. Hey, let's change colors again. Why not? So our products happen to be CO2 and H2O. So I'm going to multiply 2 times negative 393.5 kilojoules plus negative 2. Well, sorry, we have to multiply by the coefficient. 4 times negative 241.82 kilojoules. And then we're going to, well, it's products minus reactants. Put in the methanol, which is 2 times negative 201.2 kilojoules. And then plus that for oxygen, which is 0. And the reason that oxygen is 0 is because it's in its standard state. So look, I'm just going to point it over here and say, here's our 0 right there. And that won't play a part because oxygen is in its standard state, and anything in its standard state is 0. I encourage you to look it up in the back of your book. You'll find a 0 next to oxygen. Now we press some buttons on our calculator, and we solve for our answer. And so you'll end up with this term comes out to negative 1754. 0.28, and then that's going to be minus an additional negative 402.4. And let's add a kilojoule to each of these. Why not? Kilojoule. That's a tiny unit, but that's okay. And we press a few more buttons and we get negative 1351.88 kilojoules total. We're doing some multiplication, but then we're adding and subtracting. I look at the number of sig figs. It has to do with the least to the right of the decimal because our successive integers we're multiplying by are not a big deal. They are not considered in sig figs. So in fact, if we wanted to sig fig this, 1351.9 kilojoules. 9 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 kilojou There it is. All its glory. Hope you have yourself a most wonderful day.